That's got the right IP. Yeah, this is good stuff. This is all
Alrighty,
right,
well,
right
we're
stuff.
live, Jeff Carpenter, for
Hey,
another
hey!
for another episode or of our live Twitch streaming with Jeff, going over
That's
Python
right.
recommendation engine in Python.
We're building a graph recommender for Killrvideo Python. We're in the home stretch here. Well, I think we're in the home stretch of getting this done. So I'll show you what in theory should happen. We're actually debugging another problem. Something else broke. So we are trying to. The recent videos is not populating right now. So I seem to have broken something. Not sure how I did
All I know
that.
is I didn't do it. That's what's most
Is
important.
my video way not synchronized with my is it way out of sync? I
Let me
was
see.
kind of funny to myself. If it's not gonna bother you, then
Hold on real quick. I have
it's
to cough.
okay.
There we go. All right, let me take a look. Let's see. Here, I'm going to play. Can you talk for me, Jeff?
Closing everything non-essential. Yes, I'm talking to you. So, yeah. Oh, close maps?
Seems okay.
We'll close it all.
Yeah,
Everything non-essential is going. Everything must
non-essential
go.
personnel. All out the airlock.
That's right. So, yeah, sometimes. Here, I'm going to stop sharing for just a second and then reshare. And then hopefully we'll get that back. What do you think? Is it better? I think we're good. We'll go
Yeah.
with it for right now.
Yeah,
You can
yeah,
tell
no,
me
it's
if
fine.
anything is going bad. So, okay, so in theory, we would have the recent videos populating here. I've clearly broken something, but I don't want to totally derail what we were going to talk about today to try to
Okay.
debug that at the moment.
Right.
So, we are trying to get this recommended for you video section populated. So I have a couple different things that I'm working with here. One of them is source code. You built a Java version, so the Killrvideo Java, and I've been looking through this source code.
Okay.
A lot of the logic is in this Killrvideo Traversal DSL
Okay.
class. Oh, now I got spinny wheel. Man.
Spinning wheel, yeah, spinning wheel.
I'm gonna go presentation mode on this guy. So I'm foreshadowing a little bit here, but here's what my task was: is I was looking at different source that you have here. This is the traversal, the domain-specific language that you created,
Right.
and it's got a lot of definition. It's got operations. Oh, there's something. Actually, I haven't looked at some of these things here in a while. So, like, you have a friendly Java language operation here called rated, and then that actually is returning some gremlin expressions here, which have some different behaviors. Rated, you've got you've got watched, which is really just an alias for rated.
Yes.
You have user uploaded. So this is like creating this language that you can use in the service implementation of the suggested videos service.
Right.
That's the service that actually sits behind those recommendations. Suggested video service. So you got this is all the logic that I was trying to steal, basically.
Right.
There's like here, this is the important one. This is the one I was playing with yesterday. Tagged with. So, given a traversal that is stopped at an incoming video vertex, you assume that the traversal that you're operating on is a video vertex. Then you are going to look for the tag, which has that date that has the name that's provided, and then add an edge to that tag. And then there's this other operation called tag, which is so this DSL is like referring to pieces of itself. So I was just trying to go through all this code, and that's what I've been doing is in the Python world, trying to reproduce the same logic.
Right.
My idea was to not do the domain specific language at first, because I was just trying to kind of like build things simply a little bit at a time. So let's see. Oh, my Killrvideo Java window just took off on me. Thanks a lot, Killrvideo Java window. So you've got this.
I'm sorry, I put that evade
Where'd it
class
go?
in there the last time I was in the code. Sorry.
Yeah. Well, you know, it keeps it interesting, right? That's okay. Oh, here we go. Suggested videos service. So you have this operation like get suggested for user, and most of the logic that is in here is actually more about, you know, using futures and etc. Like it actually, the entire generation of the graph, we're using DataStax Enterprise Graph here to generate this. So you got this DSL that you're using, domain specific language, recommend by user rating. So you're selecting a particular user and then getting 5 recommendations for that particular user with a minimum rating of 4, sampling 1,000 other ratings, etc. And you're sampling, I guess, 5 movies that this user rated, and comparing that to 1,000 ratings from that other people have rated. Anyway, so most of the logic you've actually kind of delegated out to this DSL. So I'm doing the same basic concept here in Python, except my execution is very simplistic in a lot of ways. So I'm going to show you what I've been up to lately in this stuff.
I see what you did there, Jeff. I see what you did there. If you don't like my code in Java,
no, that's not.
The stuff
I'm building it up.
Really easy to read. No, I'll admit I'm playing, by the way. I'll admit, like, the DSL is great for the end goal, right? Like when you are then writing the actual code in the language of your DSL, it is really easy to read and understand and such, and that is the end goal. But the DSL itself can be a little complex, right? As you mentioned before, things kind of refer to other things in there. Like you have to kind of get your head wrapped around the chain of events that is occurring, right? To understand.
Right. And actually, I think that there's a great debate that we could have at some point, possibly not today.
Yeah.
Whereas the best methodology for introducing a domain-specific language into graph queries, the way that my natural inclination is to do it, and the way I think you did it when you were doing Killrvideo Java, is to actually literally write out all of the logic of the traversals that you're going to do first, and then factor out a DSL out of that.
Yes.
I almost wonder if, from a design standpoint, if maybe once you had some competence in this domain of graph databases, maybe you would actually prefer to start with the DSL. Because if you think about it, this is how most people develop applications, is you write the API and then you write the implementation. Or maybe you don't. Maybe you write the implementation first and write the API later. In which case, creating the DSL as a second step is a perfectly sensible thing to do. I don't know what
in the case of
best way is.
In the path that I took was to actually start with the graph schema, right? Created the schema first, because the schema is actually what generated the DSL. I didn't generate it with some command.
Yeah, that's a fantastic point. And so actually, you're right. Your DSL actually that you ended up with really heavily mirrors the schema.
That was on purpose.
I never thought about it that way.
Yeah, that's exactly what the whole point of that was, because what the intent of the DSL was to do, right? Like, okay, I took it and I got this also from people like Steve Millett and others like who wrote that stuff, right? That the intent was so someone who was, let's say someone, but funny enough, you're almost disproving this in a way from what you were just talking about in the Java code. But let's say somebody who wasn't a everyday programmer, or someone who was an analyst, or someone who was brand new to this code, they just, or something like that. The intent was, can I write this in such a way that if I took a look at my graph schema and I saw what I would expect there, right? Things like user rated video, user uploaded video, and so on and so forth, right? Could I translate that into code into such a way that I could write the code the same way? So without them worrying about the underlying implementation details of the DSL, someone would have to implement that, obviously, right? But once that was implemented, could they come into the code and could they write their traversals, I'm going to put that in quote, the same way that I just read out my schema? So that was the end goal.
So if I look at what's in your DSL, it seems like it has two flavors. I'll generalize. Two flavors of operations. Some of them are operations like literally there is a user operation, and you pass it I hate it when it does that. It passes it a user ID. I always forget to click on that, and then I lose my pop-up. Okay, so it's a user, and you pass in a user ID, and that is literally the operation that gives you the user at that user ID. Right. And then there's similar things for rated and uploaded and tagged with. But you also have other things like taggers and generate recommendations for user and other things that are not just traversing the schema itself.
Yes.
But so there's a mix.
It is.
Okay.
It is. I totally agree with what you just said. There are essentially two sets of operations. There's the ones that I would just call CRUD operations, right? I need to get data into the schema, into the graph. I need to get data out of the graph. I need to relate data that's in the graph. But at the end of the day, I need to perform the recommendation traversal, right? So, so that's where those two different sets come into play. It's almost more like CRUD operations and then business logic operations against the graph. Does that make sense?
Right. So this is my suggested video service file that I'm showing you the big blown up view of here at this point.
Okay.
So actually, you can see that some things that I wonder if I could. I haven't committed this code. I was gonna say I could potentially go back a couple of commits and show you the progression of this over time.
Okay.
But then maybe that's a little bit fancier than I should really try to do today. So I'm gonna go past this get suggested for user method here. This is what I'm working on right now. But let me show you. We haven't done this stream in a couple of weeks. Travel, vacations.
Yeah.
Won't bore you with the details. Backstory, blah, 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 right? So what I did want to show you is I have been working on, let's see, where did I do this? Oh yeah, that is the recommender. Okay, so handle user. Handle user created, this is the first thing that we got working. So if you'll remember, we have a user management service. When you add a new user in the Killrvideo UI, it calls the user management service, and then the user management service emits an event to Kafka. Our suggested video service is picking that event up off of Kafka, and it's adding a user node to the graph. Okay, and this was our first one that we got working, and I have been using the style of API that seemed easiest to me, because there are multiple ways that the DataStax Python driver supports creating and executing gremlin statements for a graph, right? The one that I'm using here is this Fluent API. There is another prime. I don't know if there's multiple other ways, but oh, of course, I would go to look at I was going to pull the documentation page up. I think I have a link to it, actually. Oh, yeah, here you go.
I bet you there's the string API, the Fluent API, and then the...
Yeah, so if you go to the Getting Started page, I don't really know that third one as well.
Right.
Yeah, so I'm sorry. So session execute graph. That's what you're talking about, right? And then you put that string in there.
Yeah.
So I'm using the traversal source, where I actually get a G G is representation of a graph traversal source, and then then you could do these fluent style APIs that look pretty similar, or let's say deceptively similar to what you would actually write in Studio.
Yes.
Because you've got all these, I'm going to Studio now, and you've got all these query, you built this notebook that you provided to me, super helpful, and so we're actually like, this is the straight up gremlin queries that we can see in Studio. So this API that I'm using, I was like, I want something that's as close to what I run in Studio as possible.
Okay.
And then, wait, there's a third one? Is the DSE the third one? Because I see the session style, and then the Fluent API style.
Mm-hmm.
What's the third style?
Oh, string. You could just do a string API, where you just.
Oh yeah. Okay.
Yeah.
Okay. Is there an example? I think there's an example in this page. Implicit. Okay, so this is the good one that I like, and then there's this other one. I thought it was on this page. Okay, you're right. The string-based one, where you can actually do like parameter substitution and that kind of stuff. Right, you just write this big long string, which is your gremlin query, but then you have like little question marks. You have question marks where you want to insert parameters.
Funny, I believe that's true, but funny enough,
there is an example.
I never used it like that. I did do it in my initial development when I was just figuring stuff out, because what I would do is I'd cheat. I would write a traversal in Studio, right, or Gremlin console. I would execute it, make sure it worked, and then I would just plop it into the string API. Go, okay, that works. Then I would make the other more fluent type, but it's not really using the Fluent API. I should mention that both use the same reference to G. If you take a look at the Java code, even though I have the DSL in place, you'll see that it uses that. You can use them interchangeably. So it just depends what you're using.
Right,
and since I was already using the DSE driver with session, it just made sense for me to do it that way.
Okay, so this was my first Gremlin query that I implemented in Python, and it was super easy, maybe even deceptively simple.
Yeah.
Because it looks very much like what the Gremlin query. I chose to name my variable graph instead of G.
Yeah.
I don't remember why I did that, but it's a convention.
Yeah.
It's a convention thing.
Right.
Yeah. Okay. So handle YouTube video added. This is the one that we were actually working on last time. So I'm pretty excited about this.
Okay.
And actually, here I think I know what I can do. Maybe this will be a bit of a. Let's just do it this way. Instead of me trying to do like switching branches and showing you demonstrating my level of incompetency with Git. I'm okay with Git, but I'm just fearful that I would be likely to do something and inadvertently lose some code, because I'm doing something spontaneous here and I don't want to do that. So
spontaneous with Jeff.
Oh, wait a minute. Okay, I got to go to the branch here. Okay, graph recommender.
Spontaneous, but Jeff-taneous.
Yeah, here we go.
We're getting Jeff-taneous right now. We're going to use that now.
I don't really even know. Oh, wait, there's one that says... Let me see if it's this one. Oh yeah, this is the one.
Let's see. Can you blow it up a little bit?
So, yeah, the last time I was working on this is like the last time we were working.
Yeah.
So this handle YouTube video added method.
Yeah.
I had this in steps. I don't know if you could trace the algorithm here, but I had this comment. First, I'm going to find the user vertex and add an edge. And so I literally did an entire Gremlin query here, right? And then I took that code out and I just said, okay, first I'm going to look up video as this thing. And
Okay.
this is a representation of a traversal.
Right. Oh, I remember this. Yep, I remember you doing
I'm going to run another traversal.
Right.
Literally a second processing step to my Gremlin engine. And I'm going to add this to video, and video is a traversal.
Right.
Do you see that?
Right.
So this is like this never actually worked right.
That's
because I was trying to build it in pieces instead of just building one big traversal like you did originally. And that's where I got into trouble, is like, you don't actually want to break this into multiple traversals. It's not that it can't be done this way. I was doing something that was kind of against the grain of how you're actually supposed to use Gremlin.
Right.
I was trying to break it up into pieces and I was actually doing multiple different traversals. And I hadn't even done this to-do step here to find the vertexes for the tags and add edges. So I was literally trying to build this thing where, okay, step one is I'm going to write a traversal that, like it says here, find the user vertex and add an edge to the video vertex. Execute that. Next, find that same video vertex and then find the user vertex that goes with it. No, I'm sorry. Okay, I mean, I was adding the video vertex, then I was locating the user and adding an edge to the video, and then I'm going through and looping for however many tags there are, checking to see if the tag exists, and blah 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 blah. Anyway, so this long convoluted set of stuff. I went back and I was like, this is really not working well. What I'm going to do instead is I'm going to do the same 3-step process, but I'm going to build a single traversal.
I noticed your traversal object earlier. Good.
Yeah. Okay. So I'm creating a traversal object, and I'm just saying step 1, locating the user.
You're also using caret user. You're using the reference. Nice.
Yeah. This is another. My impression by looking at your code is that this is convention, not required. Is that true?
That's yes. That's as I understand it as well. I myself like to be very explicit, so that's why I'm doing it the way I do.
Thank you for calling that out. So that is basically, we're saying that is a representation, like because user is a keyword in our schema. I don't know if there's a way to get confused, but caret user is a way of just making sure that we're explicit and disambiguating that.
Yeah.
Is that right?
Yeah.
Okay. Okay. So notice then that I'm just appending to this traversal.
Yep.
Right. Traversal equals traversal dot, and then I'm continuing to build with this traversal. I'm going to add a video with all the properties of it, and I'm going to say that's as video. Okay. That's my next step, is adding the video vertex. Then this next step is I'm going to add an edge from the user to the video vertex. And look how clean this is. I love this, right? Add e uploaded from caret user to caret video.
Yeah.
So at this point, the thing that I'm learning that I need to be conscious of as I'm kind of building these traversals is am I in this traversal, or what are the current contents of the traversal? Am I at a node? Am I at a vertex? Am I at an edge? Do I have a collection of vertices, for example? I mean, that's part of the mental model that I think you have to have as you're building these queries. So I'm learning the process of doing that.
And have you tried exporting any of the bytecode or logging out any of the bytecode for your traversals?
So this is one of the things that I was going to ask you about.
Okay.
I don't actually know how to do that.
Okay.
And I haven't stopped and tried to do that yet.
Okay. If you remember a couple,
I think that I have a place where I think it would be great to do that.
Okay.
So I do want to do that with you. But I'm not sure if I'm there yet. So
Got it.
Can we come back to that?
Totally. I'll just finish a thought then. If you remember, a couple streams back, right? We had one of the viewers who gave us some of that code actually, and where the bytecode came in, at least for me, really useful, is to exactly what you just said a second ago, where you're saying, trying to get your head wrapped around, like, when you add all these steps in, what object do you really have back at this point? Like, where are you at in that traversal, right? The bytecode was really neat, because what could happen is you could just take the output from the bytecode of your traversal. It would give you the full thing, right, filled out with all the references and stuff you have in here, because it's getting that from the code and that kind of deal. And then when you do that, I could just take that, cut and paste it right into Studio or Gremlin Console, and I have the traversal. I can execute the traversal right there, and then I can see exactly what I'm getting back. Am I getting back a set of vertices, a vertex? Am I an edge? What am I? And it allowed me, from the development standpoint, to take a look at where I was from a code standpoint, where I thought I was, and then kind of get my head wrapped around and grok what
Mm-hmm.
what point I was actually at in the traversal without having to go through a bunch of debug code just to figure that out, right? So it was a neat way that I could go, oh, and oh, here now look, I can add on, I can add on this step, or I can look at these properties or something, and then it started to give me kind of
Right.
more mental options of what I could do in code, if that makes sense.
Okay. No, I like all that. I want to definitely want to get there. So, okay, at this point, I've added an edge from my user to the video vertex, and then the final step is I want to create the tagged with edges that go from the video to its tags. Okay,
Okay. Yep.
so this is just regular Python list manipulation, right? For tag and tags,
Okay.
and then I'm going to continue to add to my traversal. And for every tag, I'm going to add an edge. It's a tagged with edge, and it's going to go from the video to a tag. But we don't yet know if the tag exists.
Yeah.
So, okay, this is all code logic that I stole from you.
Yeah.
Um, this operator is the anonymous traverser. This is basically
Yes.
kind
Yes.
of the, I think of this as like reset to zero. Is that a way, like, or just some? I don't know how if that's the best way to say it or not. Like it's a new traversal, in a sense that begins
I'm
from
not the
somewhere
best
else.
person to answer that.
I
That's
should look. I should really learn a good way to explain this. But what this
Yeah.
is basically doing is this is an operator that the coalesce operator is returning the first. You put like a list of other traversals, and the first one that returns a value, it returns that value. I know that much. So this first one is we're actually trying to look up and see if there's a vertex in this graph that has that named tag. So like we might get a video that's come in that's tagged with the keyword Cassandra.
Right.
So if that tag with the keyword of Cassandra exists, then this traversal will return that.
Right.
And if not, we're going to go ahead and actually use another anonymous traversal here to just go in and add a vertex with that tag, and then we're going to use the same date as when the video is added. We'll just use that same added date from the video and make that the tagged date.
Yes.
Okay, and then let's see. Oh, actually, I might want to. Oh, that's right. Yes, I'm adding a new vertex. Okay, got it. That's right. And okay, that's right. I was like, where are the properties? But it turns out if you look at the schema, the tagged with edge doesn't have any properties on that edge.
Right.
So that's really it.
Yeah.
We're done. And then we can execute the traversal by calling iterate. And then we're done. So I was so happy when I got this working.
Yeah.
But one little thing. I had to, it was, and this is gonna sound like me whining. You whine. And actually, I need to provide. I've just been working on this the past couple of days, and I have some feedback that I need to provide, which I think will hopefully be helpful to other people that come along and to some of our teams that are doing docs for this stuff. I typed this in here, this anonymous traversal, and of course, the IDE was immediately complaining. I don't know what that is.
Yep.
Right. So I do this, right?
I had the same thing in Java. I'm so curious to see what you had to do for this, by the way.
Okay. Yeah. Okay. Okay. So first thing, I went to Java. Okay. And I was
Probably
like,
saw a really
what
strange
did you
import
do?
statement.
Yeah. So I'm like, where's?
I want to say it's a static,
all
isn't
this
it? It'd be at the bottom. I usually put my statics.
I'm actually.
Oh, it's up
You
there.
know, I'm sorry,
There it
David.
is.
I'm in the. Yeah, I guess that's not it. That's from the DSL stuff. So actually, I'm in the wrong file. I really should be in.
By the way, while you're
This
looking,
sounds
Adrian
weird.
Adrian asks when you say bytecode, that's spelled BYTE code, right? Yeah, yes, bytecode as in BY, as in a byte. BYTE, not a byte code.
Killrvideo Java.
Like
Okay,
a zombie
I'm going
bytecode,
to
not a zombie bytecode.
the traversal. Here we go. Is that where I want to be? Oh, interesting. Where is that file? I don't actually see it here. I know that you're using the anonymous traversal in here.
Yeah, I'm surprised it's not there.
Oh, it's a reference to generated code. That's why. Okay, so there's some code generation stuff going on in the Java world. Anyway, sometimes I go down some blind alleys. Killrvideo Python, go to presentation mode, bam. So I actually, oh, and how do I expand this thing? Super weird. Okay, you can see it here. From line 3, from gremlin underscore Python dot process dot graph traversal import double underscore anonymous traversal. And actually you can see another line underneath that with some more traversals from this gremlin Python package.
Oh.
This took some doing, man. This was not obvious to me. So I ended up, first of all, our documentation does not go into a lot of the API. So our Python driver documentation does not have a ton on the actual API. And that is actually because a lot of this is in, let's see if I can find it here, the Tinkerpop documentation.
Interesting, okay.
So there's this gremlin Python section in here. And so this begins like, oh, here's some big clues.
Oh.
So I just literally started poking around because I was like, I did Googling, and thank you, Ned Lowe, right? Because he was the first one that clued me in. This was, I was literally Googling like gremlin Python example, and then guess what came up? Gremlin-Python-example. So I just went in here and started poking around and looking at some
of documentation,
his code. Like
for
how
the win
do
right
you
here.
do this stuff, right? So I'm like, oh, look, g.v. Look, this is looking familiar to me. It's like, what are your things? And I'm like, oh, this is where this stuff comes from. So sure enough, then that's how I got to the Python documentation, common imports, and now I feel like I'm kind of cooking, like I got it. So I know where the packages are of these things. But, oh, do I still have this thing open? Yeah. Okay, so I was like, well, where's the official API for the Gremlin Python package? Because like this Tinkerbot documentation is just like helpful stuff, right? Do you know what I mean?
Yeah. Okay.
Also, by the way, I'm sure that I can. I'm going to show you some code here. I haven't done this statics. I guess that's this thing from Gremlin Python import statics, and then apparently you can do this, and it allows you to omit package names from stuff or class prefix.
Oh, that's cool.
I haven't done it, so you're gonna see that my code is not as clean as the Java code looks.
Right.
Don't worry, we're going we're going down to the stuff here, man. Okay, so let's see.
So one thing that
this doesn't actually look as bad as it's gonna get, right?
No, and one thing to note, right, as you're going through this, I'm kind of torn on what I'm just about to say. So I guess this really comes down to style and what your end goal is, right?
Yeah.
Where in the Java version, like I said, the end goal there was to provide the DSL, so then you could essentially write the business traversal, if you will, the business logic traversal, very easily, or traversals very easily. But it means that you have complexity in the DSL that from someone trying to understand the code base, it's not linear, right? You have to pop around and look at different methods and understand how they're chaining together and such. Where you did yours more in line. You just wrote it in line. So at a glance, I can actually take a look at the page. And as you were talking about this before, at a glance, I can actually read right down and I can pretty much see what's going on. The difference, though, is that this, I would argue, is not as flexible as the DSL.
Oh, it's not. No.
But it is
it's
actually...
quick and dirty.
It's quick and dirty, and it's easier to understand from the I'm just getting going standpoint. But then, like, later on, when you're actually writing the bigger traversals and stuff, I wonder how that's going to come into play. But it's interesting because
well, yeah, you're going to see.
Uh-oh.
Okay, and I think that this is an example of stylistic differences.
Yes.
And where I think where we can actually this is okay. I think it's okay that the Python can demonstrate a quick and dirty,
Yeah.
and then you can provide the more refined example in the Java application, which might represent a more mature, Java enterprise programming language. A lot of people use Python for prototyping.
Right.
I'm
Right.
not saying it's not a real. I'm not saying it's not a real
Language.
sort of production level programming language. I'm not saying that. It's very much a real deal thing. But I'm just trying to provide quick and dirty examples
Yeah.
here.
Actually,
So
I like that.
rabbit hole.
I like that. I like having both, honestly, because it gives
Right.
us.
That's why we have different language implementations of Killrvideo too,
Yeah.
right? So different styles. That whole rabbit hole that I just went down of my search for documentation,
Yeah.
and there's more to come. There's more to come of that. I was just trying to show you how I actually got to the point of writing that, being able to get my my typing error, or I don't recognize this thing, I don't recognize this symbol, right?
Okay, yeah.
Red squigglies to go away. That was the reason. I had to go down that whole rabbit hole to sort of figure all that out. But then this thing works, and it's really easy. Like once it worked great. And then handle user rated video. Now I'm just rolling downhill by this point. Like I got this, right? So, look up the user node. A user rated a video. So I'm going to create this rated edge from the user to the video. And so I already had most of the code from the other methods, but I'm going to get the user, and then from the user, I'm going to add a rated edge, and then I'm going to go from that user, the rated edge, to the video, and I'm going to actually use my anonymous traverser here. Now I'm such a pro with anonymous traversals, right? With my video ID that I looked up, and then dot property rating, and then iterate. So like at this point, I'm feeling like this is pretty easy.
Okay.
So wait, the payoff. We need the emotional payoff, do we not?
Yes.
Okay.
Let's see it. I mean, by the way, I happened to notice earlier that your graph looks like
you already saw. I
saw that. I was like, oh, he's been doing it. He's been doing it.
For the purposes of this is just very simple. For the purposes of demonstration, we've come in here and we're in development mode because we're gonna just run some queries that are like not necessarily queries that you would run in production level settings, right? So we're just kind of in a more like a development mode here in Studio. And we're just going to grab a bunch of vertices from the graph up to 200. And then it's just going to show all the edges between them. And yes, I did go through and customize the icons.
Yeah, I noticed that. Right? Nice.
Okay. So, am I not connected right now? Uh-oh. Okay, well, we won't show you that right now. But in any case, we have this particular user here, Corrine16 at example.net, who's got interaction with a lot of videos. So they let's see. Trying to get that edge to show up. Uploaded. So they uploaded this particular video, which is download your copy of DataStax's distribution of Apache Cassandra. Looks like they also did Avengers Endgame, and they uploaded that one. I'm looking for one that they rated, if they rated anything. I mean, I suppose I could actually run a query, but... Oh, there we go. So the user Cornell16, they gave a rating of 3 to this video, which is, again, it's more Avengers stuff. Okay, so you see that this whole thing is being built up. We have users that we have, well, as you can see here in my key, I guess down here at the bottom. Might be a little bit small, so I don't know
you can
how
just
much
read
violence I'm going to do.
Yeah, you can just read it. Oh, did you go for the full screen?
Yeah, I did it. Okay, so we have tags, users, and videos, and then on this whole graph you see all the connections there. So it's like, yes, I finally have all this data in my graph, and all of this has just gotten us to the point where we're ready to actually write the recommendation piece, the recommendation engine, so to speak, which is really just a gremlin traversal.
Yep.
Boom. Okay, so One of the things that I noticed that was actually pretty funny here, that I'm going to ask you, put you on the spot and ask you
why did I do this?
A couple of questions about this implementation.
I'm gonna clear out the cobwebs of like 2 years ago or whenever I wrote that.
What were you thinking 2 years ago when you first wrote this?
Of what part? The whole thing?
I don't mean what were you thinking.
No, I know, I'm kidding.
What were you thinking?
Well, you asked me a question, then I cut off right when you asked it, so it paused in mine. What? Say it again.
No.
Oh, you're getting there?
No problem. Okay, let's go to presentation mode on this.
I'll go into remove cobweb mode. I'm going to dust cobwebs. Executing dust cobwebs.
Okay, this is an operation. Wow, why did it scroll up? That's I don't like this switching to presentation mode and then I lose my spot. That's not helpful. All right, so some things I really like about this code. Shout outs to all your friends that helped you write it. It's epic. This is the algorithm of this recommendation engine. Using the videos that I really like, in other words, those that I rated 4s or 5s.
Okay.
And really, it's not it's whoever the current user is. But
I put things in that.
You really personalize this and identify it. Like I'm gonna walk into my code as a user.
and honestly, I look at that because at this point, you're right.
I'm totally mocking you, and it's so wrong.
I was looking at it from a standpoint of I'm in Killrvideo. I have registered an account. I've logged in as that user. I have, in order for this to work, because the recommendations are in fact personalized. So it's not just any user. It is, when you look at the whole of it, yes, it's any user. But from the end user experience as they're going through it, I'm logged in and it's any videos that I really like because I've rated them high. That's where I'm coming at this, right? You know what I mean? So you're right. I guess from the code, it could be either way. That's funny.
Right. It was important that I do a quick score check. So Liverpool 5, Huddersfield Town 0. Oh. Still probably not going to win the championship, but it's important to keep track of
very important.
These things as they're occurring in real time. Probably dating. This instantly dates this video. For anyone who watches later. Okay, so using videos I really like, find other users who really like the same videos and grab videos they really like while excluding any videos that I have watched already. And actually, we are not tracking watch statistics, and I want you to know that if you register an account, this is to the viewing public, you register an account on killrvideo.com. We are not keeping track of what videos you watch.
You can watch whatever you want. As many cat videos as you want, and we'll never know.
We do, and we do know what you've rated.
We do.
We are not tracking. We are
now
tracking
we do count watches. We do count watches, but we don't track the person as they watch. That's right.
Right.
But you can do that in the traversal.
That's right. So really, all I'm saying is, where it says excluding any videos I have watched, really it's excluding any videos that I have rated. Which is important. That turns out to be important for the traversal.
That's right. You're absolutely right. I think I even have a comment about that somewhere in here.
Somewhere. I did read your code. I even read most of the comments.
Wow. I hope they were entertaining and informational.
I want to model good developer behavior to the world, you know?
I'm glad you feel that that's good developer behaver. Now I'm waiting for the shoe to
drop. I read
for the
most
stuff
of your
you're going to
comments.
call me out on.
Yeah. Okay. Now I feel we're adequately prepared for that, and I'm also fully prepared to ask you a question which is completely answered already in comments that you wrote. I'm expecting this to happen at some point.
Okay. Good.
Okay. So you're going through here. You're doing some checking. Yeah. This is your This is the DSL, right? Recommend by user rating. We've already. The expectation is we're in kind of a middle of a traversal. I think that we are, yes, we've already passed in. It says it here in the comments.
Yeah.
Start with the current user. So the traversal that we are starting from at this point, we are assuming we already have the user as the currently selected node.
Yes.
Okay.
Yes.
I am not going to try to explain this algorithm here, although we may get to it later in the Python code. I love what you've done here. This is highly readable to me and helpful, where you have a one-line comment in front of each line of the traversal. Also, at the same time, This is a really long traversal,
Yes.
and it's pretty complex.
Yeah.
And I would not be able to understand this
Neither would
otherwise.
I.
But
That's exactly why I did that.
there's all kinds of interesting little stuff in here, like this GTE operation, greater than or equals to. You notice that it's just dropped in here as a function without reference to anything else. There's these little things here and there which are like that, where like not equals and what is it? Or assign.
Yeah.
I'm like, what is this assign thing?
Yeah.
Right? And then group by.
There's some pretty esoteric commands. As a matter of fact,
scope.local.
It's funny like you're pointing out some of those because So this particular traversal is not. This isn't something that I would say is really heavily using the DSL. It does.
No, that's right. Okay, so you anticipated my question. Yeah.
Oh, you're wondering why I didn't use that for this? So here's where I would love the input.
Because you could have done this, right? You could have. This breaks down into pieces, which I'll show you nicely. Actually, here's the point. Now we're working. This is a very big clue that there's like a break in the logic, right?
Yeah.
This is. We are at this point we have a list of users. So like you could have created a function in your DSL that given a user, it is called find similar users.
Yep, that's right.
You could have broken this out as a function.
You're right.
And there's no real reason one way or the other why you didn't. Just like you didn't really have need of it. It wasn't a reusable function that you needed somewhere else. So you
there. That's it right there. Yeah.
Okay.
You're absolutely right. I mean, there are ways that this could have been broken up. Now, this is where, and this again, I think comes down to completely the style. I'm sure that there might be someone else who would take what I did here and they could totally just DSLify it, right? Or something like that.
Yeah.
So this is where, for me, I made this distinction. And funny enough, this goes back to something you were showing in the Python code that I commented on a little bit ago about how you had some parts in line and it was easier to understand. So this is where I made a distinction between CRUD operations and my business logic, right? That's how I'm looking at it.
Okay.
For the simple CRUD operations, the things where I'm adding things to the graph, I never really delete anything, but I'm adding things to the graph, I'm forming edges, that kind of deal. All of those are small reusable components that I know I'm going to use over and over and over. So I implemented all those types of operations with the DSL. However,
and funny enough, you do reuse some of them. Watched.
Yeah,
that is an operation in the DSL.
Yes, and where I can,
which screwed me up.
I did. Oh, interesting. Okay, yeah. Okay. So where I can, I did. In that case, to your point, where I could reference it, I did. But generally speaking, if I put it in the DSL, they were. I'm trying to think of how to word this. They were individual components that performed a very specific task, right? Mm-hmm. If you remember some of the examples. Like tagged with, right? That did one thing, right? Or any of the other pieces like that. They did one thing, constituent component kind of stuff that was repeatable and reusable. In the case of the traversal that you were looking at a moment ago, where you're looking at the fuller recommendation engine, I could have broken that up, but I felt like if I tried to break that up into the DSL, it would have been almost impossible to understand. Because you notice that even in that business logic, I'm going to call it a business line. This is where I'm actually now saying, all right, I'm separating between the things that manage the graph itself and then the questions I'm asking of the graph, in this case, this kind of recommendation engine traversal. So I only have one of these. Let's pretend for a moment that I actually do have multiple recommendation engines in the studio, but let's pretend I had other things, business logic like traversals that I wanted to execute. With the methodology I chose, I would have done them the same way. And the reason being is, I mean,
this is that original one in, I think this is the original recommendation engine
and to me,
in this notebook.
It's not reusable in the same way. More. It's sure, if I would have put another recommendation engine in there, it would have had similar traversal steps and so on and so forth. But as a whole, it was harder for me to break that down into the constituent parts and make it in the DSL and actually understand it at the same time. So I essentially just made a decision. My decision was the stuff that was CRUD operations and that dealt with putting things into the graph and organizing things in the graph, I did that in the DSL. Anything else that was then using the data that was in the graph to perform traversals that did something like the recommendation engine, I left inline. And I solely did that just for understandability, because if you notice, again, you go back to that code and you see all those comments I had in there. Those comments were also for me, because as I was working through that was a hairy traversal, right?
Yeah.
As I was working through that thing, there are so many little details in there. There's a lot going in that traversal. And I'll admit that I'm glad that when you first looked at it, you said it actually made it easier for you to understand seeing it inline like that. That was how I wrote it like that, partially because of what they did in the hackathon, and then partially what I did moving on. But yeah, I found that I could not keep it all together if I had it broken up all over the place. And so yeah, so I just made that decision in the way that I approached it. And yeah, you're right. I tried then. What I did is, once I created the traversal, like the watch videos you pointed out, once I created it, I went back and I was like, okay, well, what parts of this can now be called with it? You know, what parts can I actually just replace with stuff I have in the DSL that's reusable? And that's why you might see a couple pieces. I did like an optimization after. But yeah, it was for readability and for understandability, because it was such a large honking traversal and it would never be repeated. Like, there's no constituent part. You could break it apart, like what you said, like list the videos or something like that.
Find similar users, I think, could be reusable.
You could
That's my
break
counter
it apart.
argument.
Yeah, it just it wasn't.
But the thing is, you could have different algorithms for find similar users.
You could. You absolutely could, right? So maybe that's
the thing I like about that is you could swap those in and out, just to over-engineer this a little bit.
Yeah,
let me over-engineer this for a minute. I could have multiple implementations. If I had multiple recommendation engine algorithms, or I wanted to do recommendations based on similar users, right, I could literally have like 3 different implementations of find similar users.
You could.
And then I could have downstream implementations of operations that came after that were like find recommendations based on similar users. Or
you
something,
could,
right?
And that would be.
And then I could mix and match those.
And to play devil's advocate, if you look at the last in Studio, if you look at the last recommendation,
no, I'm the devil's advocate.
if you look at the last recommendation engine in Studio that I put in there in that notebook, you'll see one I got from DweeHi, and it's a different type of recommendation engine, and it's a totally different take. So that wouldn't work with that at all. So then I would have to go and create more
it's
DSL.
Totally different algorithm.
That's right. That's right. So it was just it was at the time when I was experimenting with the different engines. It was easier for me to say carte blanche, just replace a whole engine. I think, if that makes sense.
It might be a factor of how many different engineers are actually, or even data scientists, are working in this domain.
Yeah.
Right, and what sort of flexibility do they need? Let's unwind from the theoretical ideal DSL, because guess what? I didn't do one. So I don't know if I should go to the. Maybe I'll go back to your Java code for just 1 second here.
Yeah. There's
this thing here. Your recommendation engine. Because remember, map watched. Anonymous traversal watched. So find all of the videos that this user watched, right? I went ahead and unwound that DSL. So I have outrated because you had some different options and some different logic in there.
Yeah.
But for the particular path that was, I don't know how to say this, the path of the algorithm was basically very simple. And this was what it did in the code. Yeah. So I just unwound that DSL with the traversal from the Java code, and it just turned out to be this. So there's only a couple of places where I had to do this, because you did not use the DSL heavily in this recommendation engine.
Right, in that part of it, no.
I unwound that stuff, and then I broke it into chunks. So I broke the traversal into chunks like I did before in that other method. Okay, so the first part of the traversal is the finding similar users part. There's no good way that I've found in Python to get this multi-line. I didn't want to have every single line say traversal equals traversal dot. It's just visually clutter. Yes. I wanted it cleaner like this.
Yes.
So that meant I had to move all the comments into this comment block above. So hopefully it's not too difficult to follow, but you can sort of go, okay, this comment goes with this line, and this comment goes with this line, and blah, blah, blah. You know what I'm saying?
Yep.
So that's what I did. And I built this up in a chunk. So this first chunk is getting the similar users. Oh, based on who? That's weird. Based on finding similar users. Done. Okay. Part 2. Finding videos that were highly rated by similar users. I still have to do some stuff here that's like, you see this operator.assign?
Mm-hmm.
So that's the assign operator. And then again, that's one of those things where I had to go up to this import and go into that Gremlin Python documentation and find where the operator class was.
Okay.
Do you see what I'm saying?
Yep.
So it's a little bit painstaking because it wasn't obvious necessarily on how to find that. And actually, I had already done most of this before I found that great document here where it says the common imports.
Okay.
This was one of the last things that I found.
Oh, that's too bad because that would have been great to just start with, right?
I did a lot of things the hard way. So I got it all. I got it to the point last night, where I got it all to, and I compile is not the right way to say it for Python, but like where it wasn't complaining at me anymore. Yeah. And then I was actually running it this morning, and this is what I was working on before we came online. I got to go out of presentation mode here. See if I can find it fairly simply.
Fairly simply.
I run window. So you know what's a fun exercise? Go into your log of your application and just search for error. Sometimes it's fun. Oh, it looks like I've been. Oh man. Okay, that's not a good thing. I've lost connectivity. There's some interesting errors that I need to go back in. For some reason, sometimes when I'm adding a video and I try to tag it, I get this edge label tagged with, an edge with a simple label already exists. And what I realized, this is fun when I go back up here and look at my log, this video is tagged with data stacks, intro, and data stacks.
Good to see that the cardinality operator is working as expected, right?
So the graph, the cardinality we've set as being only a single link between a given video node and a given tag.
And that was exactly why that property, that cardinality was set like that. That's exactly what it's for.
I'm actually...
That's great.
I think I need to go back and check, though, in this case, if I think it's right, because the edge... This might be working okay. I'm not sure. Something I have to learn about the ins and outs of traversals is if it goes through and it's doing things on the traversal, I assume that once it gets to an error, it stops and doesn't do anything else. But because this is luckily the very last thing this traversal does, I don't have any errors in the structural integrity of my graph.
Yeah, and interestingly,
I don't know if this is conjecture, which I need to investigate.
And since you're using the Fluent API, and I'm using Session, right? The difference to me is that by the time I execute my traversal, I'm executing as a whole set of a single traversal. That's now.
So am I.
Now you are actually now, because you're using traversal variable and you're chaining them, you're effectively doing something very similar to that. But is that... Oh, okay. So you're not... That's right. Okay. You are actually now executing a single traversal. Yeah. You are. Okay. I was remembering back before when you had them separated up, and I thought that error was coming in between one of those. But no, okay. Okay, that's good, actually.
Okay, so the other thing is that I'll show you is I actually have an error. Let's see what I'm saying. Oh, maybe it's actually easier to see in here. Let me see if I did that. Maybe not. Did I log in as that user? I did. I should get a recommended videos.
Did we ever recover from your other issue earlier?
No, we didn't. Okay, I was trying to get to the point that I was at right before we started our broadcast here, which was to show you that even though I didn't have any obvious problems that the IDE was complaining about, once I actually ran the code, somewhere in this traversal, it was complaining at me that I had done something that it didn't know, like, you know what I mean, like an unresolved type or symbol or something
right. Okay.
like that. So I don't even have this totally perfect. Okay. And also the thing to notice is that I'm still returning no results, right? I'm iterating, but I'm not actually capturing any of the results. I actually have some code to write here to actually process the results and do stuff. So anyway, I'm partway through this implementation of the recommendation engine part of things. I'm actually pretty pleased with the progress. I'm assuming that as long as I have correctly translated your working, and I'm cheating, I admit it. As long as I correctly translated your working algorithm from Java into Python, it really should work.
It should.
I'm not expecting it not to. But this is where I want to get into the bytecode.
Yes.
Evaluation with you and looking what the traversal actually is.
And one other thing I might suggest is that in the recommendation traversal, I mean, each of those lines, you could technically comment out everything below a particular line and execute that. That's a traversal. And get back so if you're going to get back the list of videos, you could just execute that traversal. Do you get back a list of videos? Go to the next one. Is this filtering on everything that's excluded from this user? I could execute, just uncomment that, execute that.
Yeah, that's probably what I'll do. Yeah.
Because that way you can kind of, as you step down it, you can see, am I getting what I expect to be getting? And then you know that your inputs are good and so on and so forth. Yeah.
Right. Exactly.
This is awesome, though. Cool. You made a huge amount of progress here. And like we were talking about before, I really like, though, how you ended up going more inline with it. And I could totally see us. I like the idea of having the Python version and saying, okay, if you want to see implementation of the DSLs, right? We've got C#, we have Python, right? I'm sorry, C#, we have Java. But if you want to see it using the Fluent API, and not that you couldn't do a DSL with that, but if you want to see it using the Fluent API in a more inline way, here, we've done it that way in Python. Maybe we'll decide to do something else with Node these days or something.
I might still do a DSL for this. I just haven't gotten there yet. I'm doing a talk about this at Accelerate, and so I'm just trying to get as close to being done as I can by then.
Yeah.
And then I'll probably still have a few to-dos here and there left to go.
But this is looking, again,
it's fine.
And as you mentioned earlier, once you get one of these, then it kind of goes downhill, right? Not the project.
Right.
The work, right? Once
it's
you
a mind shift thing. It was like learning Cassandra data modeling for the first time. And once I finally understood partition key versus clustering keys, I was like, oh yeah, that makes total sense now, and I'm down with this, and I can do it. The Gremlin is feeling kind of the same way for me, where I'm starting to.
It's got a high. I believe that there's a high level of entry,
and I can read it.
Yeah, there's a high level of entry, and once you start to grok it, and once you get into it a little bit, then it starts to flow, and then once you have a couple methods implemented, and you kind of see how that works, it's like, oh, and then it just starts snowballing from there, and you go faster and faster.
Okay, well, we've reached the end of our time and then some, so I think
time just flows so fast with you, Jeff. So fast.
Well, thank you, I think.
Oh, wait. Adrian does say, oh, hey, Graph Day just got mentioned for 2020, and he provided a link there in the chat.
Oh, perfect.
So thank you, Adrian, for Day-to-Day Texas. They're a little free plug for those guys. Anyway, all right. Very cool, man. No, this is awesome. So it sounds like you'll have it all done next week. Great.
Yeah, we'll meet at the same time next Friday.
Okay.
And we will continue the implementation.
Alrighty.
And try to make some more progress. Maybe look at some bytecode. I'm looking forward to it.
Very cool. Well, awesome. And see everybody. Till next time.
All right. See ya.